Hey everyone, welcome back for another video on atomic theory. In this case, we're going to be talking about protons, neutrons, and electrons. And so one thing that I want to point out is that you're going to see this word subatomic particle often. And if you break that word down, sub means below, and atomic refers to the atom. And so subatomic just means particles that are below the surface of the atom or inside the atom. And so there are three particles that we focus on. So the first one is the proton. Now, the proton has a positive charge, and when we're counting it, we just say that it's +1. And the location is it's located in the nucleus, which is the center of the atom. The symbol that we give the proton is a lowercase p with a plus sign as its exponent because a proton is positive. The next one that we want to focus on is the neutron, and it is also located in the nucleus along with the proton. And the reason why it is there is because it is kind of the buffer in between all those positive charges, and it's neutral, meaning that it has a charge of 0. And the symbol that we give it is a lowercase n with a 0 as an exponent. And the third and final one is the electron, and the electron has a negative charge, and so we say it's -1. It's exactly opposite of a proton, and its location, depending on the model you're referring to, is either the electron cloud or the orbits or the orbitals, but because it is our most recent understanding, we say that the electrons are located in those orbitals. And so the symbol is a lowercase e with a minus sign or negative sign as its exponent. Now, one thing I forgot to put in my chart ahead of time is I wanted to talk about the mass, because all of their charges are relatively equal or opposite or 0 kind of thing, but the mass is very different. And so the mass of a proton is 1 AMU. And AMU stands for atomic mass unit. And so they essentially just said, okay, this is one proton, and we're going to compare the neutron to the proton and the electron to the proton. And the neutron is a little over 1, but in high school, we just say it's 1 AMU as well. It's really more like 1.1, but for our purposes, we're going to say it's equal in size to the proton. And the electron is interesting because it's about 0.0001 AMU, and that is because it is a lot smaller than a proton. And protons and atoms are already very small. Electrons are almost invisible. They're so tiny. And so these three particles are the main ones that we look at with our atom. Recent scientists have discovered things like quarks and other stuff, but these three are the ones we focus on in high school chemistry. And with that, we can use our periodic table to help us calculate the number of protons, neutrons, and electrons in a specific atom of an element. For example, if we look at this box for nitrogen, it refers to an element on the periodic table, nitrogen, and this box has a ton of information in it if you just know where to look. And you'll always have a periodic table on your quiz or your test, and you need to know how to use it. And so the number 7 for nitrogen, or that number at the top of the box, is called the atomic number. And this atomic number tells us the number of protons. Okay? And so with the number of protons, you can determine the identity. So for example, if I say the atom has 5 protons, I immediately know it's boron because boron is number 5 on the periodic table. The N is its symbol. All of the symbols are derived from either its Greek, Latin, German name for the word, or if it's a current a scientist who is really important to nuclear chemistry, or maybe the place. So, for example, berkelium is named after the University of Berkeley because that's where it was located when it was discovered. That's kind of more the recent ones that are man-made. The word nitrogen is the element name. And remember, all elements have the exact same, are atoms with the exact same protons. So for example, if I have 7 protons, then it has to be nitrogen, and all atoms of nitrogen have to have 7 protons. Electrons and neutrons can kind of change, but protons have to stay the same in order for it to be considered part of that element. And the 14.01 is considered its average atomic mass. And the key word here is average. This is because not all nitrogen atoms weigh the same, and so it's an average of that. That is why there are decimals in the number. Okay, you cannot have 14.01 protons. That doesn't happen. You can't have 0.01 of a subatomic particle. But it has decimals because it is an average, and in another video I will show you how to calculate that average based on each atom's relative abundance in the world. And so with this, it's important to know how we calculate some of our various things. So if I have, a question about the number of protons, okay, the main thing that I look for is the atomic number, right? And it tells me my protons. Now, if I want to know about the number of neutrons that I have, this is where I look at my average atomic mass, because as you remember from our chart before, the only things that have mass, really, because the electrons are so small they don't even count, are protons and neutrons. So our average atomic mass are the protons plus our neutrons. And so that means if I want to calculate my neutrons, I can say take my mass and subtract my protons, and that is equal to my neutrons. Now, if I want to know the number of electrons, this is where we have to consider the overall charge of the atom. If they tell us our atom is neutral, that means the overall charge is 0. Okay, and so this is because if I have protons, which are positive, and electrons that are negative, if I have the same amount of each, then it would be neutral. And so let's give an example. So if I have 5 protons and I have 5 electrons, then all of these cancel each other out, and overall I would be neutral, right? The electrons are still negative, the protons are still positive, but the atom altogether would be neutral. However, if I had something instead that had 5 protons and only 2 electrons, well then the only ones that would cancel each other out are these. And so I have less electrons than I do protons, so this would result in a positive 3 charge overall. We would say the whole atom is positive 3. And so that would be its charge. But the reverse could also be true. If I have something with 7 protons, but it has 10 electrons, then that means my 7 protons and 7 electrons cancel out. Then I have 3 extra electrons, so it would be a minus 3 charge. And so if they don't tell you anything about a charge or mention it, you assume it's neutral. And so the number of electrons are always your protons minus the charge. And that will give you your electrons. And so you always want to use that information when calculating the protons, neutrons, and electrons in a given thing. Use these calculations and put them into practice. So I have over here 6 different atoms, and these top rows are all neutral. And so this means if I want to calculate my protons, remember you always look at the atomic number for the protons. So in the case of carbon, that would mean all carbon atoms have 6 protons, all hydrogen atoms have 1 proton, and all oxygen atoms have 8 protons. Now for neutrons, remember, we take our mass and subtract our protons. Now, if you're looking at your periodic table, you always round the average atomic mass. However, if they've already given you a mass number for a specific atom, you need to use the mass number that's given to you in the problem. Because, as I said before, the average atomic mass is an average. It is not always true for every atom of that element. And so in this case, it would be 12 minus 6, which would give you 6 neutrons. And so we have 6 protons. And for our electrons, it's always the protons minus the charge. So in this case, it would be 6 minus 0, because it's neutral, is equal to 6 electrons. And so that would be how we calculate carbon. For hydrogen, over here, I'm going to switch colors actually so that they're all a little bit different. So hydrogen had 1 proton. For our neutrons, our rounded number would be 1 minus our 1 proton, which would give us 0 neutrons. And then our charge, or number of electrons, would be 1 minus 0, which would give you 1 electron. And so we can see that hydrogen has 1 proton and 1 electron and 0 neutrons. And for oxygen, we know that oxygen has 8 protons, and because it's number 8 on the periodic table, so for its neutrons, we would say 16 minus 8 will give us 8 neutrons. And because it's neutral, it is our 8 protons minus our charge of 0, which gives us 8 electrons. And so now we can do this practice where they are not neutral. And in this case, I wrote their charge all as an exponent, which is how you'll see it in symbolic notation, which we'll talk about next. And so for carbon, we know that carbon is number 6 on the periodic table, so it has 6 protons. And we know for its neutrons, it's still the same process. We say 12 minus 6 protons gives us 6 neutrons. And for the electrons, here, this is where we say, okay, we have our 6 protons minus a charge of 4 is equal to 2 electrons. So those are all the electrons that are available. And pardon if you can hear the grandfather clock going off in the background. Let's take a look at hydrogen. So hydrogen, again, still only has 1 proton, and that's because in order for it to be hydrogen, it has to have 1 proton. And for our neutrons, again, we take the mass of 1, we subtract our 1 proton, and that gives us 0 neutrons. And for our charge, we take our 1 proton and we subtract 1, because that is our charge, and it is equal to 0 electrons. So this particular atom of hydrogen has only 1 proton. And if we look at oxygen, oxygen has 8 protons, and its mass would be 16, and we subtract those 8 protons, and it gives us 8 neutrons. And then for the electrons, it would be 8 minus a negative 2. And so when you're subtracting a negative, it turns positive, and so that actually means we have 10 electrons available. And that rings true because that means we have 2 more electrons and we have 2 negatives. So 2 more electrons than we do protons. And so that is how we would use that to calculate protons, neutrons, and electrons using our periodic table.